Yes, welcome. Today we are going to be learning about an electrical component known as resistor. Electrical component known as what? Resistor. What is the work of a resistor in an electric circuit? What is the work of a resistor in an electric circuit? I already told us what an electric circuit is, isn't it? Connection of electrical components using wire across the terminals of a cell, isn't it? So if one of those components is a resistor, what is a resistor? What will be the work of the resistor? A resistor is any electrical material or conductor which forms resistance. Which forms what? Resistance to the free flow of current in the circuit. You understand? Current is flowing like this. All of a sudden something is there preventing the current from flowing easily. So that thing that is there preventing the current from flowing easily is known as what? A resistor. It's known as a what? Resistor. Is that clear? That component that prevents the free flow of electric current in an electric circuit is known as a what? Resistor. Is that clear? And this resistance is measured in what? Ohms. You understand? The ability of a resistor to resist the free flow of current is measured in what? Ohms. It's measured in what? Ohms. And resistors are made of what? Wire. You understand? Carbon or what? Graphite. That is wound round and what? Insulator. One round and a what? Insulator. You understand? That's how you make a resistor. Is that clear? So now you look at the factors that affect the resistance of a wire. What can make the resistance of a wire to be so big or to be so small? What are those factors? Jambo will ask you, which of the following is not a factor affecting the resistance of a wire? And the options we have here is what? Length of a what? Wire. It can be a factor that can affect the what? Resistance of a wire. Cross-sectional area of the insulator plate, temperature of the resistor, or what? The nature of the material that the insulator is made up of. Is that clear? Those are the factors that can affect the what? Resistance of a wire. One is what? Length of the wire, cross-sectional area of the resistor, nature of the material that the resistor is made of, and what? Temperature. Those are the factors that affect the resistance of a wire. Now we look at the determination of the what? Effective resistance of two or more resistors connected in a circuit. Every big circuit that will do a very great amount of work is normally made up of two or more numbers of what? Resistor. It's not only one resistor. So how do you calculate the total resistance or the effective resistance in the circuit? Is that clear? So if you look at the connection here, who can tell me the difference between how this resistor 1, resistor 2 and resistor 3? Who can tell me the difference between the connection here and the connection here? This first connection is not what we know as what? Series connection. Whereas the second one is what we know as what? Parallel connection. Can you see this one? It's moving from one resistor to the other. You understand? Through the wire back to the terminal. But this one is what? This one diverges. You understand? It's having one resistor on top of the other. You understand? Whenever you have a structure like this, we call it what? Parallel what? Connection, because they are in parallel lines. Can you see the resistors? They are in parallel. But this one that is meeting one after the other, the terminal of this one meeting with the other one is known as what? Series connection. Is that clear? So whenever you want to find the total resistance for a series connection, you simply do what? Add up the individual resistance. Is that clear? You just add them up. Simple mathematics. Is that clear? But whenever you want to calculate the effective resistance for parallel connection, you have to do the reciprocal of the effective resistance is equal to what? The reciprocals of the different individual what? Resistance. Is that clear? So you make this REF the subject. You understand? And solve down for you to get the effective resistance here. But here it's very, very simple. You just add up. So if this is 3 ohms and this is 2 ohms and this is 1 ohms, what will be the total resistance, effective resistance? It will be what? 3 plus 2 plus 1, which is what? 6 ohms. You understand? But if this one is 3, this one is 2, this one is 1, can it be 6 again? It will not. You have to get the reciprocal and solve down the mathematics. And that's what we are going to do in the next class. You understand? We are going to look at how to solve these problems. Is that clear?